This should help you with number 39. So number 39 is asking for a unit vector in the direction of this vector. We haven't talked about that yet. So one thing about vectors is you can move them anywhere, okay? And it's still going to have the same component form. For instance, I could put this vector, and it's easy to think about if it's at the origin, okay? So it starts here at 0, 0 and goes to 3, 0, right? Because the vector is 3 in the x direction, 0 in the y direction. I could also put this vector, say at 1, 1. So this is 1, this is 1. So I could also have it start at 1, 1. Now where does it end up? Well, now it ends up at 4, 1. It still has the same component form, all right? So now for this problem though, back it up a little bit, we just want to have a vector that goes in the same direction as this vector, but is only a unit vector. A unit vector is only 1 unit long. To find the unit vector, you're going to take the component form, you're going to take the component form and divide by its magnitude. So if this is vector v, we're going to divide it by the magnitude of vector v. Okay? Now, if you remember how to find the magnitude, it's going to equal your x component squared plus your y component squared. Take the square root of that. So in our case, we have 3 squared plus 0 squared. Take the square root of that. We get the square root of 9, which we know is 3. It makes sense. This vector is 3 units long. Now, we need a vector that's only 1 unit long that goes in the same direction. So the formula is divide this vector by its magnitude. We just found its magnitude to be 3, so divide each component by the magnitude. So 3 divided by 3 is 1, 0 divided by 3 is 0. This is a unit vector in the same direction as the other vector we had. Okay, so here's your answer for this one.